Hello stars, welcome back to a new video. Over the past 3 years, I've shared a variety of projects on this channel, most of them built around AVR microcontrollers. But now we've reached a key moment. It's time to take a big step forward and move into the world of ARM microcontrollers. That's why in this video I'll be showing up in person. So stick around, let's get started. This video is sponsored by PCBWay. More on them later. So here's the deal. I had a microcontroller from the STM32 series, but the only header board I had was from F1 series. And the problem was I couldn't just plug this microcontroller into a breadboard. To get around that, I used a breakout board designed for this type of chip. Now, this was my first time doing something like this. So yeah, I was a bit nervous. Be kind. Unfortunately, I didn't have the proper tools for soldering SMD components. So I used a clothing iron instead. With some trial and error and a fair bit of cleaning up messes I made, I finally got it done. Afterward, I carefully checked every single connection. And surprisingly, everything looked fine. After that, I went ahead and soldered the pin headers. Quick tip: always clean your board after soldering. It really makes a difference. I personally use thinner for cleaning. So, safety first. I always wear safety goggles and mask when I'm doing that. It took 5 days for the components to arrive, but fortunately the hard part was already done by then. Next, I opened STM32 IDE and started a new project. Right away, it asked me to connect to the internet to download the firmware package for the F0 series. No problem. I typed in the name of my microcontroller, selected it, and moved on. Then I gave the project a name and selected one of the GPIO pins as an output. You will notice when you did this, the pin changes color in the interface, which is super helpful. After that, I went to the System Core tab and clicked on Debug Serial Wire. This highlights the 2 pins you will need to connect to your programmer. Then I head over to the RCC tab and enable the Crystal Ceramic Resonator option, which automatically assigns 2 more pins for the external crystal. And finally, I open the clock configuration tab and enable both HSE and PLL clock to set the microcontroller's clock speed to 16 MHz. Quick note, this microcontroller can run at up to 48 MHz. But since I'm using a breadboard setup, I recommend keeping it at a lower frequency for stability. Now you don't need to do anything else. Just click on Build All to open the coding window. You should write your code between the start and end lines. For example, I wrote this code to make an LED blink inside an infinite loop between those lines. Then click Build All again. Next, you need to look for the hexadecimal code file in the folder where the project files are saved. But if you don't see any such file, here's how to fix it. Go to Properties, then under C++ Build and Settings. From this part, enable the option to generate hex code. Now let's move on to the programmer. Following the instructions written on the programmer, I connected it to the microcontroller. Next, I open the STM32 ST-Link utility software and load the generated hex file. Then click on this option, but it didn't detect the target. I followed the troubleshooting steps as guided. But still nothing happened. So I disconnected the programmer's power supply and instead I used the 3.3 volts power from the Arduino and it worked. I even reduced the program delay and it worked perfectly. Alright, I'm really happy with how this simple experiment turned out. You can even design a header board with a crystal oscillator for it. And for this purpose, I highly recommend getting help from my amazing sponsor. This video is proudly sponsored by PCBWay. PCBWay offers top quality PCB prototyping service. You can get an instant quote for any of their services with minimum quantity requirements. They also offer CNC machining, 3D printing, injection molding, and more. For more information, check out their website and Instagram page. Links are right below this video. Alright, let's dive into the STM32 Microcontroller development board. This one's from the F1 series. At first I thought programming it would be super easier because it has a USB port. So I added the board to the Arduino IDE just like I've done before. Selected the microcontroller's part number and wrote a simple blink sketch for pin 13. Turns out, programming this microcontroller through USB wasn't going to happen, so I went back to the previous method. I found the hex file and after a few resets, I mean a lot of resets, I finally got it working using the ST-Link software. So, what do you think about ARM? Do you like it? If you do, make sure to like this video so the YouTube algorithm can show it to someone who really needs it. Thanks for watching.